Very good morning. In last class, I already discussed about laser configurations. Here, there are three configurations in lasers. First one is two laser configuration, three laser configuration, and four laser configurations. Last class, I already discussed about this, how the process is going on this particular each and every laser. Okay. Next, in this session, in this class, now I am going to discuss about laser beam outputs. Okay, na? Laser beam outputs. Here the laser beam outputs are actually there are how we are getting a laser output of the laser. There are in the form of four forms we have to get laser beam outputs. Laser beam output. First one is that is continuous wave output, and next one is pulsed wave output, and third one is Q switched output, and fourth one is mode locked laser outputs. Mode locked laser output. Here, first one, the continuous wave output. The continuous wave output. Here, in any lasers, the characteristics affects the laser performance are the power output and mode of emissions. The characteristics of it can affect the laser laser performance by power output and mode of emission. Continuous, here there are the four outputs: continuous wave, pulsed wave, and the Q switched and the mode locked lasers. Continuous wave laser emits a continuous beam of light as long as medium is excited. Next, pulsed laser. In this pulsed laser, the output of the laser is in the form of pulses. Okay, it emits the light only is in the form of a pulses from a femtoseconds to a few seconds. Okay, here we concentrate in pulsed wave outputs. The range of the output is, we have to concentrate first of all. The output is in the form of femtoseconds to the seconds. Okay, next, third one, Q switch laser. The Q switch laser, the pulses from the micro to nanoseconds are produced. Okay, na? The range of the Q switch laser, micro to nanoseconds are produced. Next, mode locked laser. In mode locked laser, pulses from picoseconds. To that is femtoseconds up to 10 to the power of minus 15 seconds are produced. Okay, na? These are four laser beam outputs. Next, laser beam output. Here now laser beam output. This is continuous wave output. This is pulsed wave output. In continuous wave output, each and every time the output is there. In pulsed output, the output is in the form of particular interval of the time. Okay, that is continuous laser beam. These are the continuous and pulsed. Okay, the remaining two outputs are there. The remaining two outputs are very important. That is Q switched output and mode locked outputs. Now I am going to discuss about each and every one in detail. Next, before I am going to the Q switching and the mode locking, first of all we have to know about the optical resonator. We all of you know about what is the resonator. Okay, na? A resonator what is resonator? Also, it is also called as a resonant optical cavity. It is a cavity. Particular optical cavity is an arrangement of optical components which allows a beam of light to circulate in a closed path. Particular closed path beam of light that is circulate from the one end to the another end. In each and every end, particular mirrors are reflected mirrors are there. Okay, here in optical resonator there are two types of the optical resonators are there: linear resonator and circular resonator. In linear resonator, the output of the particular resonator is in the form of a linear output is in the form of a linear output. In circular resonator, the output is reflected within the particular cavity. Okay, na? in linear, first of all, that is linear resonator. Here this is, here this is one mirror is there, here also one mirror is there, this is also mirror is there. Here this is linearly we are getting some output. Okay na? Here these are made such that light becomes back and forth between two ends of the mirror. Okay na? Any two ends of the mirror. For continuously circulating light, there are always counter propagating waves which interface with each other to form standing wave pattern. Okay, standing wave patterns. Next, this is about linear resonator. Next, in ring resonator. In ring resonator, light can circulate to in two different directions. It has no end mirrors. There is no end of mirrors. Here, see here how the light is reflected within the particular on that region only, on the particular cavity only. Okay, na? Here this is in this ring resonator, the light is reflected from here to here, here to here, here to. These are three are mirrors. Actually, these are three are mirrors. Next, laser Q switching. The next topic, that is why, because I am discussing there in resonators. In Q switching, that is important part. What is that? The resonators can play a very important role in Q switching, laser Q switching. In Q switching, laser Q switching, what is the Q switching? Where we are using what is the purpose of the Q switching? First of all, we have to know about this. Here, this Q switching, we have to use it for that to get the very short pulses of the very short pulse output, to get the very narrow output, short output or the narrow output. We are using this Q switching technique. Okay na? Okay na? If it is the output pulses, if it is wider output is there, now we can, that light, we can't transmit that particular light over the longer distances. We require only narrow output. Narrow output means that is the, here we have to transmit the particular laser that is light in the over the longer distances. Okay. Next, in Q switching is a way of obtaining short pulse from a few nanoseconds to a tens of nanoseconds. Okay, few nanoseconds to a tens of nanoseconds. That is powerful from a few megawatts to a few tens of megawatts of pulses of lasers. Finally, we are getting a few tens of nanoseconds of laser output or to few megawatts of watts of laser output. Here in this Q, what is the Q meaning? Means that the quality factor. It indicates the quality factor. Okay, na? Particular any resonator, whatever the resonator we are using, the Q switching we are using. Okay. Next, if it is depending by using this Q, we have to decide whether our laser is stronger, our laser light is, we have to, that is transmitting over the long distance or not. If it is my Q value is, my quality factor value is high, here we have to know that means that light is transmitting over the longer distances. How we can say that the longer distances? Because the losses are very less. The quality factor is high, the losses are very less. If it is quality factor is low, the losses are more. We can't transmit the light, laser light in the over the longer distances. Okay, na? That's why this Q switching, here the quality factor, it can play a very important role in laser applications. Okay, na? The term Q switching refers to an abrupt switching of the cavity Q from a low value to a high value. From that a low value to the high value. Okay. Now, here in Q switching, it is a ability of the laser device to store photons or in the form of energy in laser cavity is called Q value of the laser. Okay, na? Q value of the laser. In Q switching, actually what is the Q switching? The definition of the what is the Q switching definition? It is a technique for obtaining energetic short pulses. That's it. It is a technique for obtaining the energetic short pulses, that is from a laser, by modulating intracavity losses and thus the Q factor of the laser resonator. After we are getting some laser output, we have to modulate that laser output. Okay, na? In Q switching technique. In Q switching pulse is also called gained pulses. One more name is that is gained pulses. This technique is mainly applied for the generation of the nanosecond pulses of light energy and peak power to solid state bulk lasers. Solid state lasers. Okay, this is about laser. It is a technique for the obtaining the energetic short pulses from a laser by modulating in the intracavity losses. Okay, na? Intracavity losses. This is Q switch. Next, here in Q switching techniques methods, there are two methods are there. How we are getting a particular output in the Q switching? There are two methods are there. First method active Q switching and next method is passive Q switching. Okay, na? There are two methods are there. In active Q switching, whatever the losses are there, the losses are modulated with an active control element called a active Q switch. Here, when a laser light is transmitted, it is traveling over the longer distances. If it is some losses are there, that losses become modulated by using some external device, by using some external active control element. Means that is we are using some external components and external device. We have to minimize that losses. That losses, okay, na? That losses, that is nothing. That technique, this we have to minimize the losses. That process is nothing but is in the form of a active Q switching. What are the components? How we are minimizing the losses? Modulating losses. For the modulating of the losses, what are the there are three ways are there for the modulation purpose. First way is mechanical devices. Now I am using some external mirrors or that shuttlers or chopper wheels or the spinning mirrors. By using the spinning mirror, external shuttlers or the choppers, we are I am inserting on the particular laser beam direction. Okay, na? We have to minimizing the losses. And next, second one, electro-optic device. And in electro-optic device, how I am modulating the particular losses by using focal cells and Kerr cells. Focal cells and Parker cells and Kerr cells. We know that here the Parker cells, when we are transmitting, suppose this is my laser light. This is my focal cells. This is my focal cells. It is reflect. It is after we are getting some output here. The ray, it will some incident ray. We are getting some incident ray that with some an angle it is incident in the this laser. That is nothing but that is focal cells. In this focal cells, generally we are using ADP. That is crystals we are using. ADP we are using. Okay, next third one, Acousto optic devices. What is this Acousto? By using this Acousto optic devices also, we are to modulating losses. Here, out of these three techniques, three methods are there. In these three methods, the pulse is formed after electrical signal only. The pulse is formed after electrical signal only. Okay, this is about Q switching. Active Q switching. Now, passive Q switching. The passive Q switching, in this passive Q switching, when the laser light we are giving in any medium, it itself only it will generate it acts as the minimize the losses. Okay, na? It in passive Q switching. Here it is also called as self Q switching. That's why it is also called as self Q switching. Losses are automatically modulated with the saturable absorber by using a saturable absorber. Okay. Now pulse is formed as soon as the energy stored in the gain medium has reached a sufficiently high level. Sufficiently, that is high level. When it is reaches the sufficiently high level, then we are minimizing the number of losses. Okay, we are modulating the losses. Here, the Q switch is a saturable absorber. Okay, that is saturable absorber. This is about passive Q switching. Next. Now I am going to Q switching. What is the crystal? First Q switching, active Q switching. Now and on the active Q switching, the first method. Now I can place separate crystals or any splitters or mirrors by placing any mirrors. Now we are minimizing the modulating the losses. Okay, na? Here now for this. Here we have to perform this Q switching action. The laser crystal. This is the laser crystal which is modulating that modulation of our losses purpose. Here now I can place here this laser crystal. Here these are the two mirrors are there. Two end mirrors. This is end mirror. Starting mirror. The active medium is excited. The active medium is always excited without feedback. Without feedback. Now by blocking the reflect from one of the end of the mirror of the cavity. Okay, the end mirror is then suddenly allowed the reflect. Suddenly allowed the reflect. Suddenly applied feedback causes a rapid population inversion is occurred. If it is population inversion is occurred, here in a result a very high peak power output we are getting at the output end. Very high power output we are getting at the output end. This is first one, laser crystal. How we are getting output intensity of the particular output. Now gain cavity, this is gain loss. Gain cavity versus gain loss. Here the loss is this much of loss is there. When we are applying without feedback, suppose without feedback, now we are getting this output, gain cavity output. Suppose at the short duration of the pulse only we are getting this one, laser output intensity of the particular laser. Now we are getting this narrow, very narrow output we are getting here. Okay. Next, first one, techniques for next one is the techniques for Q switching using a mechanical driven device. First one is the first method is what I am discussing in the first method. On the first method, the mechanical driven device, by using that mechanical driven device, now I can minimizing the modulating the losses. How? Here a rotating prism. Now I can place one rotating prism or any mirror. By using any rotating prism or mirror, now we can, by rotation of the mirror, when we are rotating the particular mirror, the misalignment of the particular origin axis, when it is reaches the origin axis of the particular laser, we are getting the short output. Okay, now rotate one of the mirror about the axis perpendicular to the laser. Rotating the speed cannot be made very large. Q switching does not take place instantly. Okay, next. Second one, electro-optical switches. In electro-optical switches, the light passes to the one polarizer. Okay, the light is always passes to the one polarizer, and an electro-optic cell That means the electro-optic cell is always control the phase and polarization of the laser beam. The polarization means that is the way, the direction of the particular laser light. Okay, na? The direction of particular laser light. When appropriate voltage is applied, the material inside the cell becomes B fingerprint. Okay, na? B fingerprint. By varying the voltage, cell blocks a transmit beam. Okay, cell its blocks and transmit the beam. Two kinds of electro-optic switches are used, namely Kerr and focal cells. Name Kerr and focal cells. Here this is focal cells. Focal cells. After focal cells, here we are getting here the laser beam output. We are getting here. The focal cell switches in a few nanoseconds from a quarter wave plane to nothing. If suppose before now I am using this focal cells, how the output is there? If it is, this is the polarizer, this is polarizer, this is crystal, one crystal, this is mirror. Now I am transmitting one laser light from here to here. Here there may be chance of getting some it is then due to the losses the laser light goes to the this is loss of laser light. After when I am using the polarizer technique, here before switching light becomes circulate on the first pass and then horizontal on the next and is then rejected by the polarizer. It can be rejected by the polarizer. After Q switching, what happened? Light is unaffected by the focal cells and hence is passed by the polarizer. When we are using the polarizer focal cells, there is no loss is there. There is no loss is there. The light is directly passing from the polarizer. Okay. Next, Acousto optic shuttler. In Acousto optic shuttler, what is we are using? In Acousto optic shuttler, generally I am using a quartz crystal, ADP. A quartz crystal and ADP we are using for to minimize the what is this? To minimize the losses. Okay, use a quartz crystal. Here in radio frequency and beam detect output on the output of the cavity yielding high loss. Okay, radio frequency half beam transmit the cavity with low loss. Here these are the two mirrors are there. What is this? Yeah, this one quartz crystal. Now I can place here RF transmitter is in the form of a quartz crystal and one amplifier. The quartz crystal output, the laser beam output we are giving to one amplifier. That output we are giving to another end of the mirror. Okay. This is the way of we are minimizing the losses in Q switching. Acousto optic shuttler. Next, passive Q switcher. Okay, na? Passive Q switching. Here in passive Q switching, initially the light output absorbed by dye preventing reflection. Okay, na? That it is absorbed by dye preventing reflection. After a particular intensity is reached by dye is bleached allows to high. Bleached allows to high. Here now the reflection from mirror is possible, results in rapid increase in cavity gain. Rapid increase in cavity gain. These are the mirror. This is it acts as the saturable observer is act as the here it is a self-generating device. Next, mode locking. Mode locking. The next technique in laser, that is mode locking. In this mode locking technique, what is mode locking? Actually, this mode locking technique is we are using in the communication applications. Okay, in communication application, particular region only we are getting high peak output. At the particular interval of the time, we have to lock particular time. At that time only we have to get some output. That is nothing but a mode locking. Okay. Now, mode locking technique is that generate here also to generate the very sharp beam outputs, sharp beam or laser beam output to generate ultra shoot optical pulses in a range of femtoseconds to femtoseconds. We are using a mode locking. The principle of mode locking is here. Here the mode locking it is achieved by looking together the phase of all oscillating axial laser modes having slightly different frequencies. Okay, interface between these modes causes these are mode locking waveforms for mode locking waveforms. Here in this mode locking wave outputs, finally, when we are seeing these are outputs for mode locking. At this point, we are getting a narrow output. At this portion, we are getting only narrow output. Okay, na? In each and every pulse, at the time of the high interval, high only, we are getting the particular output. Okay, this is mode locking. Now the detail when when a laser is oscillating with various modes. Okay, the laser is oscillating with various modes. Yeah. When laser is oscillating with various modes, and if modes are uncorrelated, the output intensity is always we can represent it by using that is I of t is equal Ne naught square. When modes are locked in phase, the output intensity is given as I of t is equal n square E naught square. N square E naught square. Okay, these are the standard formulas in mode locking. See here. Random waves out of phase. These are all the waves are there. These are in each and every this one wave, this one wave, this one is laser ray, this one is laser ray. Each and every ray there is no relation is there. Out of phase. Out of phase. There is no relation with there is no that is coherence is not there. Coherence is not there. Here if we are locking, if suppose if we are at the particular time we have to lock. Okay, na? Lock. That means there is no change. At the time there is no change. The phase, there is no phase difference is there. At the time we are getting this output. Narrow beam output. Okay, na? Now here locked is there. Here locked is there. Here locked is there. At the time where the locking is there in phase with the phase and with the coherence is there. Now we are getting a narrow beam output. These are mode lock. Now I am locking this area. Now I am getting sharp out. Now I am locking this area. Now I am getting sharp out. 5 modes. Number of the modes. Here in this laser light, how many modes are? Modes means how many laser lights are there? Modes. 50 modes are there. Okay. Locked mode. When here now I can lock the particular area. Now I am getting narrow beam mode. Here. In this pulse, the t, how we can determine, how we can calculate the t, but that is t is equal to n L by C. Okay, na? That is equal to 1 by n delta of Vc. That is equal tau is equal to 2 pi L by Nc. That is equal to 1 by del of Vc. These are mode locking. Yeah, in this mode locking, a mode locking of the electromagnetic field is induced by fast modulating crystals, that is active mode locking, or saturable observer passive mode locking. Here also active and passive. Mode locking fundamentally multi-mode phenomena. It is working on the fundamental multi-mode phenomena. More number of the modes we can transmit at a time. That time we can use in this mode locking technique. Okay, with this mode locking and Q switching is completed. In this tomorrow session, now I am going to discuss about types of lasers.